Welcome to Simultaneous Equations Level 3. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 2f plus 2g equals 14 and 5f minus 3g equals 19. Now to solve this, we want to eliminate one of the variables, which means we need to either get rid of the f's or get rid of the g's. And to do this, we need the same number in front of each pair, and we don't have that at the moment. So looking at the two equations, we could multiply the first equation by 5 and the second equation by 2, and we'll have 10f in each equation. Alternatively, we could multiply the top equation by 3 and the bottom equation by 2, and this will give us a 6g in the first equation and a minus 6g in the second, and we can add these together to eliminate the g's. I'm going to go with the second option because I think adding is a little bit easier. So I'm going to make the number in front of the g's the same by multiplying the top equation by 3 and the equation at the bottom by 2. I need to make sure that I multiply everything in both equations by these values. So starting with the top equation, we have 2f multiplied by 3 is 6f, 2g multiplied by 3 is 6g, and 14 multiplied by 3 is 42. Moving on to the second equation, 5f times 2 gives us 10f, minus 3g times 2 is minus 6g, and 19 times 2 is 38. Now, as mentioned earlier, because we have opposite signs on our g's, to eliminate them, we're going to add them together. So adding the top and bottom equations together, starting with the f's, we've got 6f plus 10f gives us 16f. The plus 6g added to the minus 6g becomes 0, and on the right, 42 plus 38 gives us 80. We can now solve this equation to find f by removing the times 16 in front of the f, and we can do this by dividing by 16 and doing the same on the right. On the left, the times 16 and the divide by 16 cancel out to give us f, and on the right, 80 divided by 16 is 5. So f equals 5 is the first part of our solution. To find the second part of our solution, so to find g, we need to take this value of f and substitute it back into one of the original two equations. And the first equation looks simpler to use because it has a plus in it. So starting with 2f plus 2g is equal to 14, we're going to substitute f for 5, so we have 2 times 5 plus 2g is equal to 14. Since 2 times 5 is 10, this gives us 10 plus 2g is equal to 14, and we can now solve by first removing the 10 from the left-hand side. And since this is a positive 10, we can remove it by subtracting 10 from the left and also subtracting 10 from the right. And on the left, the plus 10 and the minus 10 cancel out to leave us with 2g, and on the right, 14 minus 10 is 4. Finally, to remove the times 2 in front of the g, we can divide both sides of the equation by 2, and on the left, the times 2 and the divide by 2 cancel out to leave us with g, and on the right, 4 divided by 2 is 2, so g is equal to 2. And this means that our final solution to problem 1 is f equals 5, g equals 2. In problem 2, we're solving 2r plus 3s equals 1 and 7r plus 2s equals minus 22. Now again, we'd like to eliminate either the r's or the s's, and we need the same number in front of each pair in the two equations. So in order to do that, we could either multiply the first equation by 7 and the second equation by 2, and this would give us 14r in both equations. Alternatively, we could multiply the first equation by 2 and the second equation by 3, and this would give us a 6s in both equations. And although either of those options would be fine, I'm going to go with the second one just because we're using smaller numbers. So I'm going to make the number in front of the s's the same by multiplying the top equation by 2 and the bottom one by 3. So starting with the top equation, 2r times 2 is 4r, 3s times 2 is plus 6s, and 1 times 2 is 2. For the bottom equation, 7r times 3 is 21r, 2s times 3 is plus 6s, and on the right, minus 22 times 3 is minus 66. Now, since we're eliminating the s's because we have the same number in both, and the signs are the same, we're going to subtract them. So subtracting the bottom equation from the top equation, we have 4r minus 21r gives us minus 17r, 6s minus 6s is 0, and on the right, we've got 2 minus minus 66. So 2 minus minus 66 actually gives us 2 plus 66. and 2 plus 66 is 68. We can now find r by solving this equation, and we need to remove the minus 17 from in front of the r, and we can do this by dividing by minus 17 and doing exactly the same on the right. On the left, the times minus 17 and the divide by minus 17 cancel out to leave us with r. 68 divided by minus 17 gives us minus 4. So r is equal to minus 4 is the first part of our solution. To find s, we want to substitute this value of r back into one of the original equations. And the first equation has slightly smaller numbers in, so I'm going to go with this one. But the second equation would also have been fine to use. So 2r plus 3x equals 1 becomes 2 times minus 4, since we now know that r is minus 4, plus 3s is equal to 1, and 2 times minus 4 is minus 8, so we have minus 8 plus 3s is equal to 1. Now we can solve this by first removing the minus 8 from the left hand side, and we can do this by adding 8 to the left and also adding 8 to the right. And on the left, the minus 8 and the plus 8 cancel out to leave us with 3s, and on the right, 1 plus 8 is 9. We can now remove the times 3 from in front of the s, and we can do this by dividing by 3 and doing the same on the right. On the left, the times 3 and the divide by 3 cancel out to leave us with s, and on the right, 9 divided by 3 is 3, so s is equal to 3. And this means that our final solution to problem 2 is r is equal to minus 4, s is equal to 3. In problem 3, we're solving 5x plus 3y equals 22 and 2x plus 4y equals 20. Again, we'd either like to eliminate the x's or eliminate the y's from these equations, and the choice is ours. I'm going to eliminate the x's, and I can do this by multiplying the first equation by 2 and the second equation by 5. And this is going to give me a 10x in both equations. So starting with the top equation, 5x times 2 is 10x, 3y times 2 is plus 6y, and 22 times 2 gives us 44. On the bottom equation, 2x times 5 is 10x, 4y times 5 gives us plus 20y, and 20 times 5 gives us 100. Now, since we're eliminating the x's here and they both have the same sign because they're both positive, we're going to subtract them. So we can either subtract the bottom equation from the top equation or the top equation from the bottom one. It doesn't matter which way around you do these, it looks slightly easier here to subtract the top equation from the bottom. So let's do it that way. So 10x minus 10x is 0, 20y minus 6y gives us 14y, and 100 minus 44 gives us 56. To solve this equation, we can now remove the times 14 from in front of the y by dividing the left by 14, and we need to then do the same on the right. And on the left, the times 14 and the divide by 14 cancel out to leave us with y, and on the right, 56 divided by 14 gives us 4. So y equals 4 is the first part of our solution. We now need to find x, and we can do this by taking this value of y and substituting it into one of the original equations. I'm going to choose the second one because although they both have a plus in them, this has slightly smaller numbers. Substituting y equals 4 into this equation, we have 2x plus 4 times 4 is equal to 20. Now 4 times 4 is 16, so 2x plus 16 is equal to 20. We can now solve this first by removing the plus 16 on the left, and we can do this by subtracting 16 from both sides. On the left, the plus 16 and the minus 16 cancel out to leave us with 2x, and on the right, 20 minus 16 is 4. Finally, we can remove the times 2 from in front of the x by dividing by 2 and doing the same on the right. On the left, the times 2 and the divide by 2 cancel out to leave us with x, and on the right, 4 divided by 2 is 2. So x is equal to 2. And this means that our final solution to problem 3 is x equals 2, y equals 4.